In this video, we're going to talk about simplifying trigonometry expressions. So in trigonometry, calculus, and other higher level math courses, you'll typically see equations that look like this one. And in order to work with them and do the things that you want to do to them, you'll need to simplify it. So I'm not going to go through the entire derivation here, but this complicated looking expression actually simplifies to just cosine of t. And so really, no matter what we're trying to do with this part over here is going to be much easier to deal with. So in this video, we're going to run through some tips on how to simplify trig expressions, and then in the next couple of videos, I'm going to go over a ton of different practice problems and show you how to simplify expressions like these. So start off, the first tip is to use the trig identities, specifically the ratios. So our base trig functions are sine theta and cosine theta. So these aren't really the ones I'm talking about. The ratios are going to be the other functions, which is tan theta equals sine theta over cosine theta, cotan theta equals cosine theta over sine theta, secant theta equals 1 over cosine theta, and cosecant theta equals 1 over sine theta. So in a lot of the expressions you'll see both in the upcoming practice problems and then on your homeworks and tests and things like that, they'll have a lot of these other types of functions, and rewriting them as the cosine or sine version can really help you find different patterns and cancel things out. So for example, rewriting secant theta as 1 over cosine theta usually lets you cancel out a cosine theta on top and bottom, and that helps you get to the final answer. The second tip is to use the trig identities and specifically the equations. In my head, I think about these as the equations because they have a plus or minus in them. So the first one is going to be this cosine squared theta plus sine squared theta equals 1. So I guess to me this looks more like an equation than these, but technically they're both equations. Dividing each element by cosine squared or sine squared helps us get the other identities. So we can get 1 plus tan squared theta equals secant squared theta, and then cotan squared theta plus 1 equals cosecant squared theta. These equations are cool because basically you can take any squared trig function and figure out how to rewrite it in other terms. So for instance, say we wanted tan squared theta. We could take this equation here. We'd have tan squared theta equals secant squared theta minus 1. Same thing for, say we wanted sine squared theta. We could get sine squared theta equals 1 minus cosine squared theta. And of course you could do this with the other equation as well, or you could even get an expression for 1. So in this case we could have 1 equals cosecant squared theta minus cotangent squared theta. And sometimes plugging this in for 1 can help you figure out some clever way to solve a problem. All right, tip number 3 is to use frequently encountered polynomial, patterns and factor them out. So one of the most common ones is to see the difference of squares, which is usually written like this. And if you see something in this form, you can rewrite it as x plus y times x minus y. In trig, obviously you're not going to have x's and y's like this. I mean, you might, but normally it's going to be something like sine squared theta minus tan squared theta. And then you can notice that it's the difference of squares, and you can rewrite it as sine of theta plus tan of theta times the sine of theta minus the tan of theta. And then maybe you'll see something like this elsewhere in the equation, and you can cancel it out or figure out a different way to go forward. There are a few other polynomial type patterns that you might see. The next one is the sum of cubes, which is going to be x cubed plus y cubed, and this can be rewritten as x plus y times x squared minus xy plus y squared. And you also might encounter the difference of cubes, which is going to be x cubed minus y cubed equals, this could be x minus y, x squared plus xy plus y squared. So again, you're not really going to have x's and y's, rather you're going to have different trig functions, sine, cosine, tangent, cosecant, any of those are possible. Tip number 4 is to find common denominators. So a good example here is to show, say you have this expression that you're trying to solve for, 1 minus tan squared t over 1 plus tan squared t plus 1. And we need to figure out what this simplifies to. What you're going to do is see that this is the denominator, and you're going to try to get this side to have the same denominator. So to do that, you multiply it by the denominator over the denominator like this. So you're not really changing what this whole side is worth, but now you can rewrite the top as this one expression plus 1 plus tan squared t, and then it's all going to be over the same denominator, 1 plus tan squared t. And so here, these tangents cancel out, and then we're off to the races. We can start moving forward with the rest of the solution. This will be tan squared t, and then you could figure out something else. So finding a common denominator, definitely useful tip. And then 5, this one's not as strict, or there's not really a rule of thumb to follow, but sometimes just rearranging the equation that you're looking at can help you figure out what you're supposed to do. A good example here is, say you have 1 plus secant squared t cotan t plus tan squared t. So after you do this a couple times, you'll probably be able to recognize this without rearranging. But what we want to do is we want to rewrite this as 1 plus tan squared t plus secant squared t cotan t. And now that we've got these together, we can see that this is actually secant squared t plus secant squared t cotan t. And then we can pull out a secant squared t. And it seems like that's probably like the way to go with this one. And so you can keep going on that way. So obviously, you know, the more you practice, the less this one is going to be as useful, but sometimes just changing the way that the expression looks is going to help you get over whatever is blocking you. So in the next couple of videos, I'm going to run through almost 40 different practice problems on simplifying trigonometry expressions. They're going to start off pretty easy, and then some of the ones towards the end get difficult, but we're going to use these tips basically for all of them, and so you'll be able to see how to use them.